Welcome to the Explainer. Today, we're cracking open what might just be the ultimate toolkit for curing those late-night cloud infrastructure headaches. I mean, if you work in cloud computing, you already know the drill, right? Everything's running perfectly fine until it suddenly isn't, and it's usually at like 3 a.m. So we're going to be unpacking the AWS DevOps Troubleshooting Guide, which was put out in 2025 by DevOps Shack. And let me tell you, it's an absolute goldmine for cloud engineers. Okay, let's dive into this. Now, AWS is arguably the most robust cloud ecosystem on the planet. But let's be real for a second. Even in an incredibly powerful environment like this, things break. Misconfigurations happen, you hit unexpected limits, permissions get totally tangled up. You know how it is. This guide we're looking at, it isn't about the high-level theory of cloud computing. Nope, it's about the gritty reality of what to actually do when those red alerts start flashing all over your dashboard. I really want to pause on this number for a second because it just emphasizes the sheer scale of the manual we're looking at. This document covers exactly 100 distinct operational issues, literally 100 specific real-world errors spanning compute, storage, databases, networking, the whole serverless shebang. Now, obviously, we're not going to cover all 100 today. We'd be here all week. But we are going to extract the core methodologies so you can tackle absolutely any of them. Take a look at this quote right from the author's introduction. Issues can arise at any stage of the development lifecycle. And honestly, this hits the nail on the head. It's exactly why random guessing or, panicked clicking around in the AWS console just doesn't work. We need a systematic, forensic approach to debugging here. We really have to become cloud detectives, treating every single error code as a crucial clue rather than just a roadblock. So, here is our roadmap for today as DevOps detectives. First, the DevOps troubleshooting mindset. Second, compute, EC2 and load balancers. Third, storage, untangling S3 and IAM. Fourth, databases, RDS and DynamoDB. And finally, fifth, edge, serverless and API gateway. All right, let's kick things off with section 1, the DevOps troubleshooting mindset. Because we aren't just memorizing steps here, we're actually looking for those recurring, sneaky patterns, like underlying IAM permissions and resource limits. Moving right along to section 2, compute, focusing on EC2 and load balancers. Because, let's face it, we all share the universal pain of dealing with a server that simply refuses to respond. Okay, compute is the backbone of most cloud workloads, right? So imagine this classic, highly frustrating scenario. This is actually issue number 2 in the guide. You launch a brand new instance, you're all ready to deploy, and it just sits there. It's stuck in initializing. The health checks are just spinning endlessly. So what do? Hit terminate and restart? Panic? Let's walk through the actual forensic path instead. The guide provides this exact 5-step diagnostic process. Think of it like having a senior engineer looking right over your shoulder. Step 1, hands off the server. Seriously, don't touch it yet. Check your CloudWatch metrics first for CPU or memory spikes. Step 2, look at the AWS status checks. You need to know, is this a system health failure or an instance health failure? Step 3, if it's just a hung process, a simple restart might actually clear it. Step 4, if you can SSH in, head straight to your system logs, like your /var/log/syslog or messages. And finally, step 5, if that boot volume is fundamentally corrupted, just stop wasting your time and recreate it from a snapshot. See? It's a clean, logical escalation. All right, that brings us to section 3, storage. Specifically, untangling S3 and IAM. Because if an EC2 instance can't start and S3 fails, well, the usual suspect is almost always access control. When S3 fails, it's almost always an inside job. Access control is hands down the #1 hurdle in cloud storage. And that brings us perfectly to issue 11, the dreaded S3 bucket access denied. That infamous 403 error. Now, when you see a 403, your file isn't actually broken. No, your AWS environment is actively blocking you. It's doing exactly what it was told to do. The real puzzle here is just figuring out where it was told to do that. So the crucial point is how you actually trace that denial. The guide gives us a really solid rapid-fire checklist. First up, check the bucket policy for explicit deny statements. Remember, in AWS, an explicit deny will always override an allow. Second, verify the IAM role permissions. Does the user actually have those S3 get object rights? Third, check your S3 block public access settings. You've got to look at both the account and the bucket level. And fourth, just confirm you're hitting the correct AWS region. Oh, and here's a pro tip, heavily implied by the guide. always check your CloudTrail logs. They will tell you exactly which permission check failed during that denial event. It's a lifesaver. Let's pivot now to Section 4, Databases, comparing RDS and DynamoDB. Because performance bottlenecks here require totally different diagnostic mental models depending on the service you're using. Whenever your app suddenly grinds to a halt, let's be honest, the database is usually the bottleneck. But I want you to look at Issue 22, which covers RDS high CPU, and compare it to Issue 26, DynamoDB throttling. On the surface, both of these just look like a super slow app to your users. But structurally, they require entirely different cures. Your diagnostic mental model has to completely shift depending on the database. And this brilliantly illustrates that shift. For a traditional relational database like RDS, high CPU usually means you've got some bad queries running or maybe an under-provisioned server. The resolution is to use performance insights to optimize that query, maybe vertically scale the instance size or offload some of that heavy traffic to read replicas. But then you look at DynamoDB. It's NoSQL, it's fully managed. You aren't managing CPU at all. Your symptom there is a provision throughput exceeded error. So the fix isn't just buying a bigger server, it's a math problem. You need to increase your read/write capacity units or just enable autoscaling. It's a completely different troubleshooting paradigm. Okay, moving on to our final domain, Section 5, Edge, covering serverless and API gateway. Tracing a lost packet or a timeout here really requires a deep understanding of service limits. When you go serverless, you aren't managing the underlying infrastructure, right? But you are managing the configuration, and that means you are managing limits. Let's trace 3 super common edge errors. For a Lambda timeout, the root cause is very often just hitting that default 3-second limit. So you fix it by optimizing your code or just bumping up the timeout limit. For API gateway, a 429 error means you are getting throttled. Plain and simple. And for CloudFront, a 502 bad gateway usually points to an unresponsive origin server behind the CDN, or maybe an SSL mismatch. You've got to treat the error code as the symptom and apply the exact fix. Let's look closer at curing that infamous API gateway 429 throttling error. Follow this precise diagnostic path. Step 1, verify your configured rate limits right there in the API gateway stage. Step 2, if your traffic is super spiky, increase your burst limits. Step 3, check the back end. You need to ensure your Lambda concurrency isn't suddenly bottlenecking the whole API. And step 4, over on the client side, implement retries with exponential backoff. That ensures your system can actually recover gracefully instead of just getting hammered repeatedly. So, to wrap up our forensic review, here are the core habits of a true DevOps detective. Number 1, always check IAM and security groups first. Most issues are just access problems, not broken code. Number 2, rely heavily on your CloudWatch metrics and CloudTrail logs for forensics. Stop guessing. Number 3, treat errors as symptoms of underlying limits or load constraints. And lastly, number 4, whenever it's possible, use multi-AZ and auto-scaling to implement systemic fixes. That way, the problem literally never happens again. Which brings us to our final thought. As you apply these troubleshooting steps to your own AWS environments, I really want you to ask yourself this question. Are you just playing whack-a-mole, frantically fixing errors as they pop up? Or are you using these lessons to proactively architect for resilience? Because the absolute best troubleshooting isn't about how fast you can fix a broken server. It's about building a system that heals itself. Thanks so much for joining me on this explainer, and honestly, I highly recommend checking out the full 100-issue guide from DevOps Shack to continue your journey.